Good afternoon, everyone. This is Mr. Fu. Today, I will be sharing with you my summary notes on insoluble, soluble salts, as well as the preparation of salts. This is my way of teaching students how to remember this topic facts in a different way. It may not work for everyone, but I hope by sharing this, students will benefit. So I will start with how do you name soluble or insoluble substances. It's not just restricted to salts. I also will talk about hydroxides as well. Okay, so in the syllabus, it's very important to recognize what are the insoluble and soluble substances so that we can write the correct state symbol and determine the correct method of salt preparation. Okay, as we have learned in this topic, there are three methods of salt preparation, and it depends whether the salt is soluble or insoluble. The solubility of the salt will determine the appropriate method to be used, as well as the metal ions in the salt. All right. So, for example, if it is an insoluble salt, we use precipitation. If it's a soluble salt, we have to see whether it contains group 1 or ammonium ion. If it does, then we have to use titration. If it does not, we use the other method called the reaction of acid with excess metal, or carbonate, or base. Now, for insoluble substances, all carbonates are insoluble except group 1 and ammonium. The common group 1 metals that they will always ask in exam is sodium and potassium. So some teachers or myself have this habit of telling students, oh, remember for carbonates, just SPA. All right, SPA, SPA. S stands for sodium, P stands for potassium, and A ammonium. Hydroxide will be very similar. All hydroxides are insoluble except SPA and two more, calcium and barium hydroxide. They are actually sparingly soluble, but in writing the state symbol, you can just simply write them as aqueous. They are more towards the aqueous side, although they are not as soluble as the group 1 hydroxides are. Then we have the chlorides. This also applied to iodide and bromide, okay, because they are in the same group, halogens. Now, silver and lead 2 chloride are the two insoluble substances. The rest of the chloride are all soluble. So I try to let you know that the way to remember this is Al, chloride. Yeah, A stands for silver, L stands for lead. Okay, next one is sulfates. Barium, calcium, lead 2 sulfate are all insoluble except the rest. The rest of the sulfates are all soluble. So my student has a way of remembering this. She used the subjects that she learned, bio, chem, and physics, because for lead, the symbol is PB, it starts with P. So that's how she remembered. But for me, I have another way. I just call them BCl. So if it's not these three, then all sulfates are soluble. Soluble substances, all nitrates are soluble, quite easy to remember. Everything is soluble with span. Why span? Some of my students prefer the word span, but actually I will just put spa, okay? Because one of my students said that it's not easy to remember the word spa for him. So he want to use the word span because he want to relate Am to ammonium. That's up to him. But for me, it's easier to just recognize as spa. So as long as you see sodium, potassium, ammonium in the compound, it will be soluble. All right. So the first method I will go through is titration. So I'm going to show you how to remember them using mnemonics or acronyms. All right. So what I did here was list out all the possible salts that can come out in exam. Okay, all the possible one. All right. And the possible reagents that you can use to prepare the salt. All right. So the method is written here. So I categorize it under BRIP, then a space, SCFD. All right, B stands for burette. So you prepare your acid in the burette by filling it up with acid or alkali, up to you. And note the initial burette reading. P stands for pipette. Then you pipette your alkali into your conical flask. And then you add your indicator, which is represented by I. It will be good that you can remember some indicator like metal orange indicator and remember the colors in acid, alkali, and the endpoint. So the solution in the conical flask is alkali. So the metal orange will turn yellow in the presence of alkali. And then you add acid into the conical flask from the burette until endpoint where the indicator shows a color change to orange. Record the final burette reading and calculate the volume of acid to neutralize as alkali. And then you use the word R, repeat. So repeat the step 1 to 6. It'll be easier if you can actually write down in number steps so that you can simply just put the word repeat, step 1 to 1, instead of saying repeat from which part to which part. Yeah, it will be easier for the teacher to mark, easier for you to remember as well. All right, so when you repeat the steps, right, you don't use the indicator because the indicator will contaminate the salt solution. All right, so just now you calculate the volume of acid. That is important because you need to repeat the experiment using the same volume because you know that by using this volume, you neutralize the alkali and there is no excess acid or alkali in the conical flask. Then after that is I leave a space. We go on to heat the salt solution till saturation, which is represented by S. S means saturation. I use S because the word saturation is very important. Without the word saturation, you won't get the marks. Okay, you need to mention to heat till a saturated solution is formed. And then you put C. C stands for cool and crystallize to get the crystals. And then F, filter. And then add small amount of distilled water to the crystals. Okay, I forget one is W, wash. You wash or rinse with cold distilled water, just a little amount, and then you dry the crystal with filter paper. So this is the sequence. I hope this will help you to think of the first word. And then you still have to write all the steps down. Like for example, step 8, right? You cannot ignore evaporating dish. You need to talk about where do you transfer your salt solution to, all right? And then for precipitation method, right, these are the common salts that they will ask and the suitable reagent that will be used to prepare the salt. These reagents are not the only answer, okay? So for convenience sake, you know that to prepare precipitate, you will need to use soluble reagent. All right, so my advice for you is for the metal or for the metal ion in the salt, in the precipitate, right, I will advise you to choose another salt that has nitrate because all nitrates are soluble. This is my recommendation. Just remember, for example, you're given silver chloride. So what's the reagent? Just think of silver nitrate. Lead chloride, just think of lead nitrate. So always relate to a salt that has nitrate. It will be easier to remember. All right. As for the other side, right, I teach you something that's easy. If you see whatever anion they give here, chloride, sulfate, carbonate, or what else they have, hydroxide, whatever, you just choose a group 1 sulfate, a group 1 chloride, a group 1 carbonate, a group 1 hydroxide. It works all the time because you know that all group 1s are soluble. All right, all group 1 products or group 1 compounds are soluble. So just choose a salt that has nitrate and the other one, right, you choose a group 1, either sodium or potassium salt. You get what I mean? Yeah, that would be very convenient for you to do if they ask for the reagent, which they always ask in exam. And then definitely for this topic, there will be equations that you need to write. Yeah, it's very commonly asked. So I use acronym AFWD. This is the easiest method. So there are only 4 steps. So you add the sodium sulfate to barium nitrate, for example, to prepare barium sulfate precipitate. Mention the beaker, and then filter F to get the residue, and then wash W with distilled water to remove impurity because some impurity could be still soluble. So they ask you why you need to wash because there are still soluble impurities stuck with the precipitate. So you need to wash away to ensure that precipitate is pure from the impurities. And then you dry it with filtered paper. The last step is always the same, dry. It's always wash and dry, if you notice. Everything ends with wash and dry to get a dry sample. The last method is the reaction of excess metal or oxide or carbonate with acid. We call that with this method, it's just called reaction of excess metal or carbonate or oxide, whatever you choose there with acid. Okay. Now, so for the salt, right, they are actually soluble in water, but the salt is not a group 1 or ammonium salt. It's not SPA. So for this type of salt, right, you have to use this method. Okay, so you can actually add the excess. Remember, the word excess is extremely important. Okay, you need to add excess zinc to the acid and stir till effervescent stop. And then you carry out filtration to remove the zinc powder, collect the filtrate, heat till saturation the filtrate, cool and crystallize the crystal. So it's aligned with what I write here lah. Yeah, just that I forget to put a W. Yeah, I forgot. But it's similar to the titration step, the second part. The first part is a bit different where you need to add the reagents together and remove the excess residue. Because the zinc powder is in solid state. You rather it to be excess because it's easier to remove by filtration. The filtrate is soluble, so you don't want it to mix with the acid, which make it difficult to separate. All right? And then the same thing here. If you choose an oxide, right, then you have to be careful. You cannot say till effervescent stop because there's no effervescence between the reaction of acid with base. So you have to actually just say that you add till no more zinc oxide dissolve. But take note for this reaction. The nature of this reaction requires a bit of heating. So you need to mention hot acid to make the reaction proceed faster. If not, the reaction will proceed very slowly. And make sure you don't choose unreactive metal. You can choose copper 2 carbonate or copper 2 oxide, but not copper. Okay? Yeah. So that's about it for the topic on salts lah. So I hope you benefit from it. So that's it. Thank you.